Deep in the velvet black of the constellation Leo, 120 light-years from the pale blue dot we call home, a revelation has emerged, one that will rewrite the story of life in the cosmos. The James Webb Space Telescope, humanity's most powerful eye in the heavens, has found it. A world where the air hums with the chemistry of life, where the temperature lingers at a perfect 120 degrees Fahrenheit, where vast oceans ripple beneath an alien sky. The data arrived like a whisper from the void, etched into the faint infrared light that had journeyed across the interstellar expanse for over a century. Dr. Niku Medusan, hunched over his monitor at Cambridge University, watched as the spectral lines unfolded, each one a fingerprint of molecules drifting through the atmosphere of a distant world. And then there it was, a spike in the data, a signature that sent his pulse racing. Dimethyl sulfide, a molecule that, on Earth, is produced by only one thing: life. Not a trace, not a maybe, a signal so strong, so undeniable, that the odds of error were less than 3 in 1,000, 99.7% certainty. The number hung in the air like a thunderclap. The universe had spoken. We were no longer alone. The planet, designated K2-18b, is no mere exoplanet. It is a super-Earth, a world 8.6 times the mass of our own, wrapped in a hydrogen-rich atmosphere that acts like a cosmic blanket, cradling the planet in a perpetual, life-sustaining warmth. Unlike Earth, where the thin veil of nitrogen and oxygen leaves us vulnerable to the whims of space, K2-18b's thick hydrogen shroud locks in heat, redistributing it so efficiently that even the eternal night side, the hemisphere forever turned away from its dim red sun, remains bathed in liquid water. And then the implications hit like a comet strike. This world might be more hospitable than Earth itself. Red dwarf stars, like K2-18b's parent sun, are the silent sentinels of the galaxy, small, cool, and unfathomably long-lived. While our own sun will one day swell into a red giant and scorch Earth to cinders, K2-18b's star will burn for trillions of years, offering its planet an eternity of stable light. Life here would have time beyond human comprehension, to evolve, adapt, perhaps even transcend what we know as biology. But the true marvel lies in the chemistry. The James Webb Telescope didn't just find water vapor, methane, or carbon dioxide. It found dimethyl sulfide, a molecule that, as we know it, cannot exist without life. On Earth, it is exhaled by plankton, by bacteria, by the pulse of living oceans. And there, on a world 120 light-years away, it drifts in quantities so vast that they stain the very atmosphere. The implications are staggering. We have spent centuries searching for Earth's twin, a rocky world orbiting a sun-like star at just the right distance. But K2-18b is something else entirely, a planet that defies every assumption. A world where life thrives, not despite its alien nature, but because of it. And this is only the beginning. Beneath the swirling hydrogen skies of K2-18b lies an enigma, an ocean unlike anything in our solar system. Not of pure water, but of water infused with hydrogen. A churning, pressurized abyss where the rules of chemistry twist into something alien, and yet something alive. This is no ordinary sea. Earth's oceans are fragile things, bound by narrow temperatures and pressures, vulnerable to freezing or boiling away into the void. But K218b's ocean is different. Here, dissolved hydrogen acts as a universal solvent, stabilizing the water across a mind-bending range of conditions, from near freezing to scalding beyond 300 degrees Fahrenheit. Life here would not cling to survival at the edges of possibility. It would flourish. The pressure is crushing, hundreds of times greater than Earth's deepest trenches, yet the hydrogen-laced waters resist the physics that would turn them to ice or steam elsewhere. Instead, they remain liquid, a vast global reservoir stretching hundreds of miles deep. Imagine it, an entire planet's worth of water, so much that Earth's oceans would be mere puddles in comparison. And within those depths, on Earth, hydrogen is a trace gas, a flicker in the atmosphere. But on K218b, it is the foundation of life itself. Microbes here, if they can even be called that, might not rely on oxygen, but on hydrogen as their energy source, metabolizing it in ways that would seem impossible in our own biosphere. They would not exhale carbon dioxide, but dimethyl sulfide, the very molecule that announced their existence to us across the interstellar gulf. High in K218b's atmosphere, where pressures warp carbon into crystalline structures, microscopic diamonds form and fall like glittering snow. On Earth, such a phenomenon would be a wonder. Here, it is weather. The planet's methane swirls in vast storms, reacting with hydrogen to create complex organic chains, the building blocks of life, cycling endlessly through air and sea. But the most haunting question remains: what kind of life could thrive here? If Earth's extremophiles, those microbes clinging to volcanic vents or buried in Antarctic ice, are any indication, life is stubborn. But K218b is not merely extreme, it is optimized. Its thick atmosphere shields it from deadly stellar flares. Its global ocean ensures no desert wastelands, no frozen poles, just an unbroken temperate expanse. Evolution here would have no bottlenecks, no mass extinctions from ice ages or overheating. Life could grow uninterrupted for billions of years. And that raises a terrifying, exhilarating possibility. What if we're not looking at microbes? What if, beneath those hydrogen waves, something more is waiting? The final revelation of K218b comes not from what we can see, but from what we must now accept. The data leaves no room for doubt. We stand at the threshold of a new cosmic paradigm. This distant world, with its hydrogen-rich atmosphere and global ocean, has rewritten the rules of where life can exist. No longer must we search only for pale reflections of Earth. The universe has shown us something far more profound: that life adapts, thrives, and perhaps even prefers environments we once thought impossible. The implications ripple outward like shock waves. If a super-Earth orbiting a red dwarf can harbor life, then the number of habitable worlds in our galaxy may be tenfold what we imagined. Each faint red sun in our night sky, once dismissed as an unlikely host for planets, now glows with new promise. The dimethyl sulfide signature in K218b's atmosphere represents more than just a scientific discovery. It is a mirror held up to our place in the cosmos. We are not special. We are not alone. We are simply one expression of a universe teeming with possibilities. The James Webb Space Telescope has given us our first real answer to humanity's oldest question, and in doing so, has birthed countless new ones. What forms might life take in that hydrogen ocean? What civilizations might have risen and fallen over the eons of K2-18b's existence? The planet's stability means life there could be older, more advanced, or utterly alien compared to anything on Earth. As we continue to study this distant world, we must prepare ourselves for an even more profound truth. That not be unique. It may simply be the first of many such worlds we discover, each rewriting our understanding of biology, chemistry, and the very nature of existence. The discovery marks not an end, but a beginning, the opening chapter in humanity's true understanding of our place among the stars. The universe has spoken. Life is everywhere, and we are just beginning to listen.